whenever you're building a zero knowledge circuit, there are two things happening at the same time. On one hand, there is the circuit execution, like the program that you're writing that goes instruction by instruction, doing whatever you're saying it to do. But what also happens is that there is a second pass that happens after that, in which you create the proof of execution. Usually, these two go hand in hand. You just write code once, and the same code is used for both executing and generating the proof. There are some cases that you need more expressive power.
This was such a fun conversation with Santiago from Aztek, who also used to be at OpenZeppelin. We cover a ton of different things, including paradigm shifts in zero-knowledge proofs and why Aztek is building Noir. And we also covered something fun at the end.
Yeah, he gave us some pretty wild war stories from his time at OpenZeppelin. Very timely given the Viper hack that just happened yesterday. But it sounded like a Herculean effort. It was very epic sounding. So amazing episode. Absolutely amazing to talk to Santiago.
Yeah, will be a good listen, I think. So let's jump into it. We are here with Santiago, who is an engineer at Aztek. Santiago, we're so excited to have you on the show.
Hey guys, thank you for having me. It's a pleasure to be here.
Cannot wait to dive into a bunch of different things that you've worked on. You've done work at OpenZeppelin, now you're at Aztek, so I think we're going to have a ton of things to cover. But before we do that, maybe you can give a little bit of context on the work that you're doing, and maybe even before that, how you fell down the crypto rabbit hole.
Sure. So I've been a developer for the past 18 years already, so it's quite some time. I do have a life before Web3. I used to work on standard web applications. I had spent like several years doing consulting, a lot of time working with NGOs, a bit on disaster response, on disease surveillance, so pretty interesting domains. Yet at some point I decided I was looking for a change in career. And via mutual acquaintance, I happened to meet Manuel Arauz, who's one of the founders of OpenZeppelin. He's a very OG Bitcoiner, then moved to Ethereum. Just chatting, co-working space. Hey, nice to meet you. What do you do? I work in smart contracts and Ethereum. What the hell is that? This was 2016. What is smart contract? What? Started talking, started looking more into it, got into a rabbit hole, went back to Manuel and asking for a couple pointers. Hey, how can I learn more about this? And the guy ended up sort of selling me into a work test for joining the company. And a couple of months later, I was the third employee at OpenZeppelin. That's how I got into crypto, straight into Ethereum.
I love that. And I guess, so you worked on OpenZeppelin for a while, and now you're working on Aztek, which I'm curious about the context behind moving to Aztek and what that looked like.
Sure. So I think that one of the things that got me into crypto in the first place was seeing an ecosystem that had a lot of potential, yet it was, how to put it mildly, a dumpster fire, you would say. Things were super, super immature. There was a lot of room for improvement, for setting standards, for advancing the state of the art. All the basics were there, but there was a lot to build on top of that to empower developers to build strong applications on top of this new foundation. I think that's one of the things that got me most hooked into crypto. Fast forward 5-6 years, and then getting a similar feeling from zero knowledge. So started after several years at OpenZeppelin, felt like the cycle was due to close, and started looking into other stuff, did a bit of formal verification, a bit of MEV, studied different topics, went into ZK and was, this is the rabbit hole I want to go into, definitely. I had mutual acquaintance in Aztek, and also knew the team from way before, they are one of the OGs in the zero knowledge space. Much of the basic research, the very papers being published out there on ZK, come from people at Aztek. So I was like, this seems a good fit, and so far I couldn't be happier with the choice.
Yeah, I love the parallel there also between finding, an exciting part of crypto and then going, okay, how can I find an even more niche part of crypto that I want to work on that feels very promising? And I think in this conversation we'll cover both some of the stuff that you thought about at OpenZeppelin in terms of standards, and also hopefully talk about some of the things that you're working on at Aztec as well. Um,
Absolutely.
and on that note, maybe we can just start out with some of the ways that you approached libraries at OpenZeppelin and thinking about standards more broadly. I think an interesting question that we wanted to dive into in this conversation was just what role you think OpenZeppelin played in like creating standards versus sort of pushing existing standards, and what it looks like to create some of those standards in crypto more broadly.
That's a very good question. Um, I think one of the first crypto conferences I went to was ETH Denver in 2017. To give you some context, this was like CryptoKitties was just starting, and there were talks around, hey, we need a standard for NFTs. It was still pretty green to the field, but I recall like a group of people discussing about, hey, like how can we come up with a good standard for NFTs that later becomes N21. And one of them like rushing to our stand and saying, hey, we need you guys there, because if OpenZeppelin is not in the conversation, the standard is not going to happen. That's when it dawned on me like, hey, we have like real power in a way to steer the committee towards one direction or the other. Like, anyway, the point of this anecdote is that I feel that OpenZeppelin has and still has a lot of power in deciding which standards are adopted and which ones become popular. Always talking about application level standards, of course, but like being adopted, being integrated into the OpenZeppelin library means that the standard is somehow blessed in a way. And like while I was working there, we would get a lot of PRs like out of the blue from standard authors who wanted to push their own agenda, and basically they were trying to get their code into OpenZeppelin contracts as a means of getting validation.
So do you think OpenZeppelin is at a point now where it is sort of like just continuing to receive all of these developer PRs that are looking for that blessing? And do you think that OpenZeppelin has more of a stance of just like waiting to see that be established in the developer ecosystem before it starts to receive some of those PRs?
So as a disclaimer, I haven't been with the company for a year now, but based on the time I was there, like what to accept and what not to accept was a recurring conversation within the contracts team. And like the criteria we had settled on is that in order to adopt the standard, it would have to be finalized as an EIP, and it would require to have some significant adoption by the community. And also there was some sort of implicit criteria that is, we must think that this standard makes sense, actually. Like that's a bit more subjective to measure, but it was still an important criteria. I think the only exception was typed signatures. I'm not sure that standard was finalized by the time we adopted it, but it was resolved to incorporate it. There was also some period in which we had some draft implementations for unfinished standards. Anyway, it's a very, very difficult line to walk. But after one concrete standard, I don't remember the number, but it was a token implementation that we included in the library and then had to withdraw. We became a lot more wary as to what we accepted and what we didn't.
Yeah, because I guess your goal is to be sort of like unopinionated and more so just like an aggregate of established standards. You don't want to be the gatekeeper. How do you think about upgradability in that sense? Because I know every single dev that you talk to is going to have a different opinion on upgradability. How does OpenZeppelin remain sort of like objective and offer both options within the library?
I mean, at the implementation level, there are even two versions of the context library. One of them upgradable, the other not upgradable. So users can pick from whatever they want. Still, OpenZeppelin puts a lot of effort into tools for securely managing upgradability. Personally, it was also shared by more people in the company. I think that upgradability is a super valuable tool. But as any tool, it comes with its pros and cons. And you cannot just drop upgradability on top of a project. You need to have a concrete plan for it. You need to have a proper governance process. Like, you open up a whole kind of worms when you introduce upgradability, that's for sure. But for most projects, it's super valuable.
Yeah, that makes a lot of sense. So I'm super excited to get into this Aztec conversation because I think for a lot of Web3 developers, Aztec has been around for quite a bit and has always been putting out pretty cool projects. And I think given just how much is going on in the space, it's always hard to find time to like dig as deeply as you want to into every single cool project that you see. So if you could start out just at a high level, maybe give like a little bit of history about Aztec and some of the work that they've done, and then maybe talk a little bit about how you ended up joining the team.
Yeah, absolutely. Like, I think I can start with version 2 of Aztec, which is the one that became more popular, which was Aztec Connect, which was sort of, how to put it, like privacy aggregator for DeFi, in a sense that you could use Aztec Connect to shield your funds and participate in different DeFi protocols from this shielded pool of funds. So, like, you could deposit on Aave, on Compound, or Uniswap, or whatever you wanted, all from this shielded pool. So all your actions on DeFi protocols would get batched along with other users and like would be processed via a set of zero knowledge circuits. So basically, your participation in all these projects was fully private. Aztec Connect was discontinued the very day I joined Aztec. It was actually a pretty fun day for joining the company. And the idea is basically Aztec knew as a company that Aztec Connect was not the project that they wanted to pursue. Basically, the current vision for Aztec is a lot more ambitious. So Aztec Connect is centralized, which is something that's not acceptable for working DeFi and privacy. And basically, we wanted to build something that's as powerful as Ethereum, but that has privacy built in. And that's the new version of Aztec being built. Think of it as private smart contracts. Actually, the tagline is Ethereum encrypted. It's a layer 2 zero knowledge rollup that instead of running an EVM, as most ZK VMs do today, it has its own language, its own virtual machine. And what you execute is actually not bytecode, but rather you execute zero knowledge circuits. You create a local proof of execution and you submit that to the chain. That's very different to other ZK rollups, in that everything that you're doing is completely private. So it gets proven on the client, and that's what gets submitted to the chain. Sorry, maybe I got a bit too technical too early, but basically, that's what differentiates what we're building, right? Like, instead of assembling a transaction and sending that to a prover or an aggregator that will take care of batching that and creating a zero knowledge proof that gets verified on L1 to make sure that all execution was fine. What you do is you run everything locally in the browser. You assemble a zero knowledge proof of that, and you just send that zero knowledge proof to a sequencer or to the chain for processing. So the entire world has no idea what just happened in your browser. They just know what are public side effects, what are private commitments, what are nullifiers you're emitting. That's all the information that you get to see. Still, fully private transactions hurt computability a lot. So that's why Aztec, as in the Aztec Network, is going to have both private and public execution. So whenever you're writing a contract, you can define, hey, I want this to happen on private land. I want this to happen on public land. Public land is going to be a VM, much like any other rollup, any other blockchain you see out there. It's going to have its own bytecode, by the way. And it's going to be executed on the nodes by the miners. Like, transactions that happen on public land are going to have basically the exact same workflow as any other blockchain you see today. And the idea is to have very easy, very seamless interaction between the two worlds. So you can do whatever computation, you privately, exit to public land for extra computability, and go back into private whenever you need.
Yeah, I really like this mental model of like public and private land and sort of thinking about where do you want these things to happen. I think a more broad question that I'm really curious about is when you think about what it really means to develop using zero knowledge proofs, like what are the paradigm shifts between what we'll call more traditional Web3 development, which is maybe an oxymoron, and developing with ZKPs.
So there are a couple of differences. Just out working with CKP, the main thing you need to keep in mind is that whenever you're coding, whenever you're building a zero knowledge circuit, there are two things happening at the same time. On one hand, there is the circuit execution, like the program that you're writing that goes instruction by instruction, doing whatever you're saying it to do, like any other program. That's standard, that should be common for any developer. But what also happens is that there is a second pass that happens after that, in which you create the proof of execution. You make the zero knowledge proof that everything was correct, like happened according to what it was supposed to happen. Usually, these two go hand in hand. You just write code once, and the same code is used for both executing and generating the proof. There are some cases, now I'm talking about zero knowledge development in general, not in particular for Aztec Network, and you'll see this in Cairo, in Circom, in Noir, basically in pretty much every zero knowledge language, that you need more expressive power. As you need to call to an external source to get data, you need to do some computation that is maybe not very well supported on the constraints land that will generate the proof of a circuit. And when you do that, you need to drop into what we call unconstrained mode. So say, hey, I need to do some operations. Please, I just want to run this. Like, don't bother proving it. Just need to get the result. And then I, as a developer, will take care of writing the constraints, like making sure that this result is proper. This comes from an asymmetry from being able to produce a result, like make a computation and verify a computation. Like sometimes it's a lot easier to just verify that something is correct, written in mathematical constraints. And this asymmetry is a massive honeypot for bugs. There are a couple of articles out there already on unconstrained bugs on zero knowledge programming, which should draw a lot of attention for any developers that are working on this. Like whenever you say, hey, like you take the control out of the compiler and say, hey, I know what I'm doing, really. I'm going to write something unconstrained and then take care of it. I know what I'm doing really never turns well. Like you need to be super careful about what you're doing in those cases. And sometimes you really need to do it because there's just no way around that. So that's something super important to keep in mind when it comes to zero knowledge development. Then there are a couple of other things to keep in mind that are strictly related to zero knowledge development in the context of a blockchain. Like for managing private state, we need to use a UTXO model, which is not the same as an account-based model in Ethereum. So all of a sudden, everything is in UTXO, which means that if you have two people, two different transactions trying to access the same resource, basically the first one that gets there wins because they will need to consume that UTXO and create a new one with the updated state. So all of a sudden you're creating a lot of contention around transaction execution. So you need to design your application around that. So suddenly there are a lot of, how to put it, like a lot of leakage out of the abstraction that you need to take into account when working with this new model, this new paradigm. One of the things we're working on now is trying to make this as transparent as possible and like make sure that we give developers the tools so that they don't shoot themselves in the foot.
Yeah, because I imagine that's going to, anytime that a developer has to straddle multiple paradigms in their head and go between them quickly, you're opening up the surface area for areas where they might put gun themselves. Can you go into maybe an example of like unconstrained development, like where I as a developer might prefer to use unconstrained mode for some sort of execution?
Sure. There are two main situations in which that happens. One of them is when you just don't have the tools in the mathematical representation of the circuit to actually directly map the computation. Like a very, very stupid situation, very stupid example is like getting a bitwise decomposition of a number. Like you want to say, hey, like the nth bit of this number, what's its value? What's its value? Like actually doing the divisions and modules of a really big number within a field that you need for zero knowledge circuits is ridiculously expensive. And honestly, I'm not sure if it's mathematically possible. I leave that to smarter people than I do. But it's ridiculously easy to just come up with a number and say, hey, like this is the value. And then actually do the math to reconstruct the number out of, hey, the nth bit multiplied by 2 to the n and so forth. And you do that whole addition, you get the number back. Hey, cool. Like the decomposition I did originally works. That's like very, very stupid example of a place like you want to have like full computing power to do whatever you want. By full computing power, I don't mean like, hey, you need a 4-core machine to do it or 64-core machine to do it. I mean, I want to use whatever operations I want, which is not something that you can always do on ZKP. That's one area where you may need to drop into unconstrained mode. Actually, there's even a more stupid example. If you go into circumstandard library, you want to check that two variables are equal. You cannot do that. You just cannot do it. Like you need to drop into unconstrained mode and come up with a couple of tricks in order to properly express that restriction. But anyway, I'm diverging. The other scenario where you do want to drop into unconstrained mode is when you need impure functions. Like if everything is a pure function, like everything happens in a vacuum, we're all happy. But sometimes, hey, you need to read state, you need to emit an event, you need to do something interesting out of the code you're actually writing. In that case, and now I'm speaking specifically about writing ZK code for a blockchain, then you need some way to say, hey, like this is code that is going to be calling somewhere else. It's going to have a side effect, and the side effect and mathematical equation don't play nicely with each other. So basically what you end up doing is, okay, you drop to unconstrained mode, you do whatever you need to do. Maybe you query an oracle for some data, you get that data back, you verify that the data you got back is sound, and then you proceed execution.
Okay. That makes a lot of sense. When you're talking about these, this execution and proof generation, you gave the example of this could be something that just runs in the user's browser.
Yep.
But did you say that there are scenarios where you need more power and you go make an external request, or am I confusing that with something else?
Oh, sorry. An external request, I was referring not to computing power, but expressiveness, actually. Sorry, my mistake there.
Okay.
Like being able to do whatever operations you need to do that maybe you cannot do necessarily on the field that you're operating on to create the constraints for your zero knowledge.
Okay. Yeah. So I want to dig in a little bit more into this public and private world. So as a developer, I've got some contract in public world and some circuits in private world, and these need to talk to each other. Can you maybe go through an example of like a user experience that could go between these worlds, like what that looks like both for the developer and then finally for the end user?
Sure. So it's pretty similar to basically message passing across a bridge, because we're actually using much of the same code under the code for talking to Ethereum, talking between private and public land. But what happens is, from the user's perspective, when they have a transaction that starts on private land and then goes into public, execution of everything that happens privately would happen locally in the browser. They will get a result out of that immediately. After the proof is executed, transaction will get submitted, and all the effects from public execution will only be returned once a transaction is mined. It's actually processed by the network, much like in Ethereum or any other chain. So it's like they will have these two moments where they get like an initial set of side effects out of their transaction, and then the full completion once the transaction is mined. How wallets are going to translate that into an actual user experience is still very much TBD. Personally, I don't know whether it will make sense to let the user know of everything that's happened on private land, or wait until the transaction has been fully mined and then show the complete set of results. Does an end user even care about what happens in one place and the other? Honestly, I'm not very sure about that. As for the developer experience is as simple as, hey, I want to call this function. If this function lives in private land, then it's all part of the same execution flow. If not, you need to think of it as sort of an async call. Like you're queuing an execution, you're triggering that will happen when the transaction gets mined, and you cannot use the result of that on your computation.
Got it. Yeah, it's kind of funny that given how new this is, it's still not entirely clear what the user would want to see in a given private land like execution transaction. And I'm sure it's like very context specific. Like if they are doing something that I guess maybe can you give sort of a high level example of maybe like a Uniswap AMM style execution where like from the user experience, they would basically just get the thumbs up at the end to know that it worked properly? Or maybe if you have like a more complicated example, that might be better. Do you have an example?
Yeah, I'm thinking that the Uniswap example that you bring up is a good one. Basically, the user will have an initial set of private steps that go through, first of all, authenticating them. Like we're going full account abstraction on Aztec. That means that the whole step of authenticating a transaction, like basically validating the user signature, is going to happen in a contract, and that's going to happen on private land. Then moving their funds or unshielding their funds in order to participate in the AMM. Then the transaction in the AMM will happen on public land because AMMs require to happen. They need to happen on public land because of the contention on basically the assets on the pool. If you've had something more like an order-based exchange, possible that you can do everything in private, but that's not what we're focusing on here. Then the AMM would have the code for sending the assets back on as a private node, basically re-encrypting them for the user.
Yeah, I'm curious. Of course, the AMM example is like something that is an interesting and slightly different paradigm for something that we have now on Ethereum. I'm curious when you think about things that you personally are excited about that ZKPs sort of uniquely enable, what comes to mind?
Look at the stations, right? Like being able to prove anything about yourself without having to reveal any information. I think that's super powerful. That's something general of ZKP, like it exceeds a zero knowledge blockchain, right? Like the one we're building at Aztec. Like being able to prove to share any information, like up to the boundary you strictly want. I think that's something super powerful. Around the identity management, authentication, like even regulation, like being able to disclose exactly the information you want to. That's a very powerful tool. That's on one hand, and the other, just the fact of being able to prove that you did something correct without having to trust a third party opens up the door for a lot of things. Like basically anything that today depends on a secure enclave or something like that can be hacked, or I don't know. Everything can be hacked, so I don't want to open that door. But anyway. Anything that today depends on a secure hardware enclave, I feel like there's a potential to be replaced by smart cryptography in the forms of zero knowledge proofs. And that could enable some really interesting things. And also interoperability in general. Like just being able to verify from one side that, hey, the other side did everything by the book, lets you compose system in ways that I'm not sure we still fully understand.
Mm.
Yeah,
Yeah.
I always like the to the former example you gave about sort of attesting to some information without giving away the entire thing. I always like the example of when you want to prove to a bar, let's say you're in the United States, the drinking age is 21. If you want to prove to the bar that you are at least 21, you have to give them your ID, which also tells them your full address, name, like all your height, eye color, all this extra information that they don't need to know. They don't even need to know your exact birthday. They just need to
Exactly.
know that your age is greater than 21. So I always like that example. Chase, you were going to say something?
Yeah, I mean, I think it's kind of interesting because in Santiago, you hinted at this earlier when you were talking about, the next thing that feels really exciting in this ecosystem being ZKPs. It feels like when I think about what's possible and then what's been built thus far, there's definitely sort of a delta there. And so I'm curious when you think about what it looks like for developers to actually be able to use this stuff. That becomes a very different question, which I think dovetails nicely into probably your work on Noir and why that matters. So yeah, maybe first we can touch base on the delta between, and then we can dive into Noir.
I agree, the delta is massive. It's going back to the beginning of our conversation, it feels similar to the delta between the discussions of what we'll be able to build in Ethereum in the next 5 years, like in 2016, 17, versus, hey, what we're seeing now. What we're seeing is massive compared to what we had back in the day. Back in the day, we've had the DAO and ICOs. Now we have massive ecosystems, both in finance, gaming, in governance. Anyway, like many of the things we had a faint idea of what would be possible to build, but like seeing them in action is a completely different thing. And I get the sense that something similar is going to happen here. With the big difference that like all of the things we built in Ethereum were built in Ethereum. Like, and sure, L2s and whatever have you. ZKPs enable interconnectivity between existing systems. Like, I feel like it's a tool that exceeds blockchain by a lot. Sure, it can be used for abbreviating computation, for making rollups that have instant finality, and like for privacy rollups like Aztek's building. But there is still something else there that can be incorporated by more traditional systems in like regular client-server applications that will open the door to a lot of new things that we're still not envisioning. As for the second part of your question, developers today, like I think that the developer today is faced with, which language, which framework they want to use for coding in zero knowledge. There are not too many options. Circom is like by far the most popular one. It's good. It's easy to learn. It's low level. You can think of it as the C of zero knowledge in a way. You have Halo 2, which is not a language. It's a framework for Rust. I spent a couple of weeks trying to wrap my head around it. It's probably the most difficult API I've had to learn in my entire life. It's that. Like, it has a lot of accidental complexity that comes out of the API. At the same time, it's ridiculously powerful. If you do know what you're doing and you know the very low levels, the very implementation details of the zero knowledge circuit you're building, it lets you extract like massive performance out of it. And then you have Noir. Noir is probably the first truly high-level language that you have for general zero knowledge proofs, which for sure we're repurposing for writing smart contracts in the Aztec network. But today you can use it Noir completely standalone for just writing zero knowledge circuits. And it feels like an actual high-level programming language. Like, sure, you have some things like dropping into unconstrained mode, like some things that are very, very specific to zero knowledge, but for the most part, it doesn't feel like you're a different paradigm. You just code and it works.
Yeah, I'm curious. So it feels like whenever you're building something that is much higher level, you're abstracting away a lot of complexity, and sometimes that also means that you're making trade-offs in terms of control. And so I'm curious how you thought about that in architecting Noir or building Noir?
The idea of Noir basically, for full disclosure, I'm not part of the Noir team within Aztec. Noir is being developed by a dedicated team within the company, and they're doing a terrific job out of it. The idea of Noir is for making it easy to create zero-knowledge circuits. The trade-off there is basically performance, like number of constraints. Basically, performance in zero-knowledge circuit is measured in terms of gates, right? Like how many constraints, how many operations, let's say, you're doing as part of your circuit, and that directly affects proving time. Depending on the flavor of proving system that you're using, it may also affect verifying time, but in most cases, that's not too much of a problem. The main thing that you're trying to optimize is proving time. Being a high-level language, you have a big abstraction layer below you that will prevent you from doing mistakes, and that will add more constraints and basically more gates to whatever you're building. That means that if you know exactly what you're doing and you're trying to write something super optimized, most likely you will get a better performance out of Halo 2 than out of.
Okay. So would you say that, I'm not sure how much you've talked to developers that have started playing around with Noir, but I'm sure a good portion of them are also Solidity engineers and come from like a pretty heavy Web3 background. What is the learning curve off of something like Solidity if you wanted to start playing around with Noir?
Zero. Noir is Rust-based, so at the very most, you'll have a slight learning curve, just wrapping your head around Rust syntax, which is not difficult to learn, honestly. And that's pretty much it. Aside from that, it just feels like any other high-level programming language. The thing that you need to understand is like what the workflow when working with zero-knowledge applications. That's not something related to language. It's related to the paradigm itself. Like, what's a ZK app? Like we talk about dApps in Ethereum. What is a ZK app? Like, ZK app is something where you write a circuit in the form of a program, could be a circle, in Noir, what have you. And then you have a binary out of it. But what do you do with that? It's not just that you want to execute it. It's not that you just want to run a program. You want to run something, you want to get a proof out of it, you want to define who's going to verify it, you want to very clearly design what's going to be private of that, what's going to be public, basically what are the private and public inputs to the program, and how all that information is going to flow. Like, you have a different paradigm, but when it comes to the whole application, like the whole protocol of what you're building, I feel like that's the biggest learning curve that you're going to get when coming from Solidity or even from a Web 2 background. As for the programming language itself, I think that Noir has by far the lowest barrier of entry.
Yeah, I imagine that's got to be important because especially if a lot of developers are coming from that Solidity Web3 background, that's already a small kind of niche within web development. So you're taking a niche and you're carving out like a niche within it. So a little earlier, you were talking about how the usage of blockchain with zero knowledge execution is sort of like one application. Can you talk a little bit about how where do we expand the pie, go outside of just Web3? And what are sort of like what you see as the future vision for like zero knowledge more generally?
That's a very difficult question. There's a nice blog post that a coworker of mine shared recently from Cloudflare on using zero knowledge as a means of authentication, like while working on identity. Like if you want to prove who you are, like you could use a YubiKey or a Coral wallet that has a private key within, signs something on your behalf and publishes it. But that will reveal information as to, let's say, who is the manufacturer of your key and like some additional information around it. Like you could totally mask that behind a zero knowledge proof that only reveals, hey, like this signature is valid, period. So again, going back, I think that identity is definitely a use case where identity and authentication in general and authorization as well, it's going to be a use case where we'll see zero knowledge. And the other interesting area is possibly interconnectivity between systems. Like if you want to get information out of a system and you want to make sure that that information was produced correctly, well, that's zero knowledge proofs are definitely a way of doing that. ZKML is also something that's trending a lot, like basically being able to prove that the output of a computation comes from a model trained in a particular way without revealing any information out of the model. So super interesting. Like machine learning, there are many flavors of it, but at the very end, it has a bunch of linear algebra behind it. Linear algebra, zero knowledge constraints, they play with each other pretty nicely. So it's not difficult to create a zero knowledge proof out of the execution of a model on a certain input. So you can say, hey, like, can you give me the answer to this particular query? And you could get back the answer from a trained model along with a proof that says, hey, this comes from a valid trained model, which is something pretty powerful as well. Well, there are also some applications. I think that in Paris, in the context of FCC, recently there was a project that worked on creating a zero knowledge proof out of a microphone, where the idea is that you could do edits on the audio that you recorded and create a zero knowledge proof that said, hey, like these edits are valid, are within this range. Like I didn't modify the original audio in a way that altered its meaning or anything. That applies to all kinds of media, right? Like if you have an original piece of media that's somehow verified that it's true that it was produced by someone, you can apply transformations to it and prove that those transformations still preserve the essence of that original content without modifying it. Like cropping an image is probably the most stupid example, but hey, it's important as well.
One question on that note, in terms of just, this is kind of circling back on the public and private question, but also as I listen to your approach there and thinking there, it's coming up as a question, which is basically like, do you think that there's going to be kind of rules of thumbs? That's not the right way to say it, but what would you think about in terms of how individual developers think about what data should be public and should be private? Because it feels like there's one version which is like almost everything is by default private. You're using zero knowledge in almost every instance, which also seems like it maybe introduces unnecessary like friction in certain ways or potentially limits what's possible. On the other side, of course, you have things being way too public, and that's not optimal either. And so I'm curious, of course, every use case changes, but when you think about that dynamic between what makes sense to have as private and what makes sense to have as more public, like what is the approach there?
That's a very good question. I would say that everything should be private by default unless you need it to be public. And need to be public usually comes in the form of composability. Like if you need multiple people modifying or accessing the same resource, you want it to be publicly accessible, or at least accessible to that whole set of people. So yeah, I would say I would go in that direction. Yeah, like try to make everything as private as possible. And when you reach like the last point where you need to start interacting with that resource, then you make that public, strictly what you need, you make whatever changes you needed, and you go back into private lab. But I'm saying that because that's the model we're operating with right now, it's possible that we get access to other primitives that make this not necessary. I'm thinking about homomorphic encryption or crypto that's also out of my area of expertise. Or maybe even using something like CRTs or like data structures that allow you to incrementally modify a structure while being conflict free would also enable you to do some to open up composability without hurting privacy. Again, I think that the best thing we can do is put the building blocks in the hands of developers and see what they come up with.
And I imagine there is this sort of in-between world where I think you kind of gave an example at the beginning where you said something might be private to a set of people. So maybe
Yeah.
it's not like full zero knowledge privacy. Maybe it's like within this pool, you are aware of the people that are in it. And yeah, I think it just, we'll probably see the evolution of the space as we get these new building blocks and people have access to compose off of different primitives over time. I think in Web 2, we only really had the sort of like siloed, it's private to that organization, but that organization knows everything about everyone that's using that software. And then in blockchain world, it's like everything's public. Everyone knows everything about everyone. And zero knowledge is now giving us this sort of like new category of application building where it's like, okay, so now only the person creating this transaction and building this circuit, they are aware of what's happening, and it's like pretty much shielded from everyone else. I think it's kind of neat to just to think about like what that new primitive will open up for builders moving forward.
Yeah, I agree. And like this concept of private to a group of people is tricky to get because groups of people are never static. Like what happens if you have a group of people and you want to add someone new to have access to that content? You want to reveal all history to them, or only things that happen from now on? Do you need to re-encrypt everything? How do you give them access to? How do you revoke access to someone? Like knowing that they have already seen all history that has happened, they are pretty tricky.
Yeah, absolutely. Chase, go ahead.
Yeah, on that note, I mean, when I think about the open space and what we talked about between the delta of like what's happening now and what's possible and all of these things, it sounds like one of the big things that people who are interested in exploring ZKPs can do is just understand this paradigm of public versus private and the flow that you're talking about. I'm curious in terms of other starting points for people who are interested in exploring how they can leverage ZKPs in building applications. Like, what are the best places to start?
It's a good question. I am pretty sure there are a couple of awesome lists. If you want to get into zero knowledge in general, I had put out a blog post a couple of months ago when I started going to ZKP with what was my personal journey on how to get into the field. It's called a Beginner's Guide Beginner's Guide to Zero Knowledge Proofs. It's on dev.to. But I would say that probably an easy way is to find a framework or a language that you feel comfortable with and join that community. Of course, I'm going to shield Noir's Discord and Discourse and our forum as well. You can jump in there, and we have several people who are working around the clock just on helping the community and getting developers on board and like answering every question out there, frequent office hours, and basically granting all the support needed, including the form of financial support. Like if you have something interesting that you want to build in Noir and want to apply for a grant, that's also an option. So for sure, I'm going to shield the Noir Discord for people to join who want to get into ZKP via learning Noir. We're also launching a course. I think Pretty Cassidy is running it on zero knowledge using Noir. So that's also an option for getting into the space. And as usual, like probably one of the best ways is reading code out there. Like look for a project that you like, that uses zero knowledge, go through it until you understand what happens. I'm not sure if I'm legally allowed to say it out loud, but hey, Tornado Cache is great from an engineering perspective. It like ticks all the boxes on what you need to understand on what's a private transaction, what happens on a zero knowledge circuit, what's to verify the in each place. And the paper is 2 pages long, and it walks you through everything you need. There's also this team, I think it's called Match 34. Sorry if I got the number wrong. That they do this project called Button Zips, which is basically the game using zero knowledge proofs implemented in different languages. You can even play on the browser. And the idea is that the whole game is implemented using zero knowledge circuits. So whenever you as a player want to shoot the other player answers with a zero knowledge proof saying, hey, did you hit one of my bolts or you didn't?
That's pretty cool. I love little games like that that also teach you things in the process. I've also seen there's another resource list called Awesome Noir that
Yeah.
has a ton of resources, talks, like boilerplate libraries, stuff like that. So there's a
Absolutely.
lot you can do to learn in this space.
Definitely. The only difficult thing is that everything is moving ridiculously fast. So you learn something, couple months later, there's already a new way of tackling that. But okay, it's part of being on a fast moving area.
Yeah, and I guess one other thing I want to make sure that we touch on is you wrote a book on Ethereum development. So we talked about so many of the things that you've worked on and thought about. We haven't even touched on that. I think, as someone who's been in the space for a while, something that we're always curious about asking about is, I guess, twofold. One, general development, how you approach picking up and designing smart contracts and all that stuff. But I think in a little bit of a spicier form, a question there would be war stories, which is kind of design patterns have gone wrong. And so I'm curious if you have any war stories that you'd be willing to share on the pod before we wrap up.
Hey, I can think of. Yeah, I can think of a couple. But mostly around. Okay, so OpenZeppelin contracts is pretty popular, and means that there are a lot of projects out there using OpenZeppelin contracts, which means that the bug in an OpenZeppelin contract will affect a lot of projects. It can happen. Like we have, while I was working there, we had received at least one report of a critical vulnerability on a contract, and it's critical vulnerability. So, sure, you produce a fix, but how do you roll it out? Like, it's an open source library. You cannot just say, hey, there's this critical vulnerability on every contract. Everything is public out there. Like, all of the people who use this are basically screwed. So we started a very, very difficult process of identifying every single person who had ever used that version of the contract across every single EVM chain out there, which was not easy. We had a lot of help. We had the Tenderly folks and the DDoP folk help us a lot. They both keep like index versions of the blockchain they index different stuff, but out of the information they had, we could guess who were all the contracts out there that were affected by this. And so, we ended up with a list of a couple of hundreds, and from that start filtering on trying to understand which were test contracts, which were production grade contracts. And then the funniest part is trying to figure out who owns each contract. So it became a very lengthy process of going from address to trying to understand, okay, this belongs to this particular project. And for the most part, we managed to deal with that. The surprising part was that once we knew what that project was, it was super difficult to contact them. Like, you would be amazed to know how many projects don't have a contact info, an email address, a valid domain, something for reaching out to them. You would expect that any user doing more than 15 seconds of due diligence out of a project would stay out of something that doesn't even advertise an email address to reach out to them. But no, we're talking about projects who had millions of TVL on them, and there was no way to reach out to. We did our best. Like, we hopped into the Discords, like looking for admins, sent cold Telegram messages, Twitter DMs, whatever we could. We managed to get to most of them. And at the end of the day, to the best of our knowledge, there were no funds lost due to the vulnerability. Actually,
Wow.
this will happen in 2 occasions, and one of them, we could actually take over the contract to prevent the attack from happening. So we had like a mitigation transaction that we could send that would basically prevent that hack from happening. It's not that we took over ownership, we just delegated ownership to nothing. But that would prevent any attack from happening. So we basically coordinated to execute the same transaction across hundreds of contracts on all EVM chains at the same time, like quieter than Satchel altogether. None of them got front run, and we managed to execute the mitigation. That was
Wow.
definitely fun. Yeah.
That is quite a war story. Yeah, that is absolutely wild. And I suppose if an OpenZeppelin dev contacts you, answer is the key takeaway there.
Yeah, absolutely. This is also very timely given the Viper vulnerability that was found yesterday.
Oh, yeah.
That was like that did not go as well as what you just described. There was a lot of money lost.
I guess that I don't know. I haven't been following it very closely. I know that there are a lot of efforts towards recovery. So anyway, all I'm going to say is all the best to the people who are actually dealing with the fallout of this, because I know how stressful it can be.
Well, this was an incredible conversation, Santiago. Thank you so much for joining us. I feel like we covered a ton of different topics, and also I love the war stories. And I didn't even think about the fact that, particularly being at OpenZeppelin, the war stories aren't just like, single battles. They truly are an entire war. So it's always fascinating to hear that. I know you plugged Noir and Aztec, but one final plug: where can people learn more about you, the work that you're doing at Aztec, and all of the things?
I try to be pretty active on Twitter, so you can follow me on Twitter, SN Palladino. It's my handle. That's mostly like anything interesting that happens is going to be on the Twitter feed, including a link to this podcast, of course.
Beautiful. Love that. Well, Santiago, thank you so much for coming on the show. This was so wonderful.
Thank you for having me. I had a lot of fun.